Okay, hi everybody. I'm gonna start working on homework problems for 4.4 real quick. I'm gonna jump right in here, and I think I'll do a couple of problems. But first, we're gonna start with question 2, and so you can see what we've got here. It says 11% of the world's population speaks English as their native language. If we randomly select 11 people, okay, so that's your sample size or your n. So I'm just going to put n equals 11 here. From anywhere in the world, what's the probability that 5 of them speak English natively? Okay, so that would be x equals 5. We're counting successes. That's native English speaker. The little p is the probability of a success. So the probability of success is, because 11% of the world speak English natively, that's an 11% probability if you pick one of them randomly. Okay, and of course Q is 1 minus P. So 1 minus 11% is 89%, like that. And I think we're ready to do the formula. It's the probability that x is 5, pardon the dog, is n choose x, p to the x, q to the n minus x. Okay, so n choose x, that's 11, choose 5. P is 0.11, so 0.11 to the x, that'll be the 5th. And Q is 0.89, so 0.89 to the 11 minus 5, like that. And I think I can do this on the calculator now. So I'm doing 11 choose 5 here. The NCR button right here, press it twice to get the choose, and then 5, we'll hit enter. So that's 462, and so I want to multiply that. Here's a 462, then times 0.11 to the 5th. And leave the exponent, and then times a 0.89 to the 11 minus 5. Okay, and so that's probability. It wants 3 significant digits. So just a reminder, you don't start counting till you get to the first non-zero digit. So 0.369, that's 3 digits, but the next digit's a 7. So I'm going to put in point, 2 zeros. Let me zoom in on this just a little. Okay, so 2 zeros, then a 370. That's 3 significant digits. The mean, I think I can squeeze in the mean here. So just down below on my tablet, mu is n times p. So n is 11, p is 0.11. So 11 times 11 is 121. So I'm guessing this is 1.21 here. So I'll put that in, 1.21. I'm going to just check my answers here. There is a place to do that, right? And then the variance, I'll do the standard deviation first. So real quick, standard deviation is the square root of NPQ. Okay, so that would be the square root of 11 times p, which is 0.11, times q, which is 0.89. Okay, and so let me do that. Second square root 11 times 0.11 times 0.89. Okay, and hit enter, and I think, let's see here, the next three questions, 2 places after the decimal, so I'm going to do 1.04 for the standard deviation. There, and then the variance is the square of the standard deviation, so I can just, on the calculator, I can just square the last answer here for the variance, 1.0769. Okay, so I'll just do 1.08, I think, and let's check all those. So these are all fine. Okay, so that's the end of that question. All right, so I'm going to jump back now to question 3. And this one's a little more involved. Okay, so this one does a quick review of just all the details of a binomial experiment and the formula for a probability here. I think I'll do one of these by hand. We've got n choose x here. We do that automatically on the calculator. The mean is n times p. Standard deviation is square root of npq. All right, so that's all of our formulas that we need. I'm going to go ahead and just update what we've got here. So pardon me while I erase my last workbook. I'm sure there's a better way to do this. Okay, so so on this one it says 69% of the U.S. adults are vaccinated from COVID-19. That's going to be a success. So we'll call that success as a vaccine. Okay, and looks like we're picking 6 adults randomly, so n is 6. Okay, we're going to do x from all the x values from 0 to 6. Okay, again, little p is the probability of a success. So success is being vaccinated, and 69% of us are vaccinated theoretically. And so that's the probability, little p, probability of success. Q is 1 minus p. So if 69% are vaccinated, then the complement is of that, you just do 1 minus 69%. 0.69, you get 0.31. Okay, and now the formula for the probability of x is here. I think let's do the probability of 4 successes. So just for this one, I'm going to do x equals 4. Okay, and so the formula would be n choose x. That would be 6 choose 4. Okay, and then p is 0.69. To the x, we're saying that's 4, and q is 0.31. To the n minus x, that would be 6 minus 4. Like that. Okay, and I think I'll do that over here on the calculator. So real quickly, Let's do this 6 choose 4. Just run that. So it's 15, and we'll say times the rest of the computation. We did the 6 choose 4, that's 15, and then times 0.69 to the 4th. Okay, leave the exponent, and then times 0.31 to the, it says 6 minus 4, and of course that's just 2. And there's our probability. I'm going to round this to 0.327. And this one, except it says we should round to 2 places after the decimal. And we're doing that because we're going to be graphing these. So I'm going to change this to 0.33. And that was the probability that x was 4. 0.33. Okay. And we need to do the rest of these. So I'm going to show you real quick. We need to be able to do one by hand and show the work for your exam. But once you know you can do these by hand, then at some point you want to start doing them, having a little help. So the calculator will do this, and if you, I learned how to do this. You want to go do a memory clear and then go into data. And in the first column, put your x values. So they'll be 0 through 6. I'm going to go ahead and do that real quick. Like that. All the x's are in the first column. And we're going to put the probabilities in the second column. So what you do is you clear from here. And then instead of doing data, we're going to do second data where the distribution menu is. Okay, we're doing a probability distribution here, so that's why we're going to use distribution. I press second data, and then we arrow over to distribution, and if you arrow down, you'll see there's a binomial probability density. It's called probability density function, but for our sakes, it's probability distribution function. And I'm going to hit enter, and then what I want to do is I'm going to make a list of all the probabilities. And so if you hit list and enter, you have to tell it how many trials there were. There were 6 trials, and the probability of success was little p, that's 0.69, like that. And then the values for x we put in L1, so you have to load those in advance, the 0 through 6 for x. And then it'll output the probabilities to list 2. So that's pretty cool. We just hit enter through all that. And so here are your probabilities. This 8.9 times 10 to the negative 4 is what this means. It's telling you to move the decimal 4 places to the left, and you're going to end up with 0 when you do that. So let me just put it up on my little sheet here. If you have an 8.9, what is it? It's 8.9. So 8.9, and the E negative 4 is telling you to move the decimal 4 places to the left. So that's what that does. And then you fill in with zeros, like that. So it's 0.00089, and of course that rounds to 0. So I'm just going to put a 0.00 there. And with 1 success, you can see it's 0.01. For 2 successes, it's going to be 0.07. Okay, for 3 successes, you can see it's 0.1957. We're going to just make that 0.20 with a rounding. Okay, and oops. And then over here, for 4 successes, it should be 33%. Let's check. Yeah, that's right. It rounds to 33%. 5 successes is going to be 29%. And then 6 successes, last one, about 11%. So we'll put 0.11, like that. Okay, so those are all of our probabilities. Should be okay. Looks good. Now the mean, just a quick reminder, is n times p. So I'm going to do that on the little whiteboard that I have here. So n was 6 and p was 0.69, like that. So I'm going to clear out here and just multiply that. So 6 times 0.69 is 4.14, and it says 2 places, so we'll go 4.14. Okay, standard deviation, we do the square root. I think I can, yeah, I've got it here on the white pad. So the square root of NPQ. So n is, where is it? 6. P is 0.69. And Q is 0.31. Oops, hang on. Okay, so we'll do that real quick. Square root of n, which was 6, times 0.69, and then times 0.31. So that's standard deviation. We're going to do 1.13 over here. And for the variance, we square that, so we'll just press the x square button over here. And so we get 1.28. So we'll check our answers here to make sure everything's good. And it looks like everything's good. Okay, so now I got to slide up the probabilities. This first probability is 0, and you got to be careful because the machine won't register it unless you move that bar, so you got to pull it up, drag it back down to a 0. The next one I think was 1%, 0.01, and then after that was a 0.07. Like that. The next bar was 20, then 33. Like that. Then we had a 29 and 11. Like that. So there's the histogram. It does look a little skewed to the left. The left tail's longer. Let's go ahead and see. I think it'll ask us those questions. So yeah, here's our histogram. Looks good. There's no mistakes. It computes the skewedness as negative 0.3. Whenever it's negative, it's skewed to the left. And the kurtosis comes out to be 2.8. That's a little low. Remember, a normal, the standard kurtosis for a bell curve is 3. So this has short tails compared to a bell curve, which is called platykurtic. And we should be good to go. And that's it for the homework.